Hello friends, today I am going to reveal some true facts of Mars Curiosity, facts and information. But first of all, I request you to please share and subscribe my channel for getting my informative true facts videos uninterrupted. Please note that subscription of my channel is free of cost. Now, Mars Curiosity, facts and information. The Mars Science Laboratory and its rover Counterpiece Curiosity is the most ambitious Mars mission yet flown by NASA. The rover landed on Mars in 2012 with a primary mission to find out if Mars is or was suitable for life. Another objective is to learn more about the red planet's environment. In March 2018, it celebrated 2000 sols, means 2000 Mars days on the planet, making its way from Gale crater to Eolis Mons, that is colloquially called Mount Sharp, where it has looked at geological information embedded in the mountain's layer. Along the way, it also has found extensive evidence of past water and geological change. Curiosity is as big as an SUV. One thing that makes Curiosity stand out is its sheer size. Curiosity is about the size of a small SUV. It is 9 feet 10 inch long by 9 feet 1 inch wide, that is 3 meter and 2.8 meter, and about 7 feet high, that is 2.1 meter high. It weighs 2000 pounds, about 900 kilograms weight. Curiosity wheels have a 20 inch 50.8 centimeter diameter. Engineers of NASA Jet Propulsion Laboratory designed the rover to roll over obstacles up to 25 inches, that is 65 centimeters high, and to travel about 660 feet, that is 200 meters per day. The rover's power comes from a multi-mission radioisotope thermoelectric generator which produces electricity from the heat of plutonium-238's radioactive decay. Science goals. According to NASA, Curiosity has 4 main science goals in support of the agency Mars exploration program. 4 main science goals, that is, determine whether life ever arose on Mars, characterize the climate of Mars, characterize the geology of Mars, prepare for human exploration. The goals are closely interlinked. For example, understanding the current climate of Mars will also help determine whether humans can safely explore its surface. Studying the geology of Mars will help scientists better understand if the region near Curiosity landing site was habitable. To assist with better meeting these large goals, NASA broke down the science goals into 8 smaller objectives ranging from biology to geology to planetary process. In support of the science, Curiosity has a suite of instruments on board to better examine the environment. This includes cameras that can take pictures of the landscape or of minerals, close-up mast camera, Mastercam, Mars Hand Lens Imager (MHL), and Mars Descent Imager (MARD). A spectrometer to better characterize the composition of minerals on the Martian surface. Alpha particles X-ray spectrometer, that is APXS, chemistry and camera, ChemCam, and chemistry and mineralogy, X-ray diffraction, X-ray fluorescence instrument, ChemIn, and sample analysis of Mars, SAM, instrument suite. Radiation detector to get a sense of how much radiation bathes the surface, which helps scientists to understand if humans can explore there and if microbes could survive there. These are Radiation Assessment Detector (RAD) and Dynamic Albedo of Neutrons, that is DAN. Dynamic Albedo of Neutrons means DAN. Environmental sensors to look at the current weather. This is the Rover Environmental Monitoring Stations (REMS). Rover Environmental Monitoring Stations (REMS). An atmospheric sensor that was primarily used during landing, called Mars Science Laboratory Entry Descent and Landing Instrument (MEDLI). A complicated landing. The spacecraft launched from Cape Canaveral, Florida on November 26, 2011 and arrived on Mars on August 6, 2012. After a daring landing sequence that NASA dubbed 7 minutes of terror, because of curiosity that NASA determined that the past methods of using the rolling method with land bags would probably not work. Instead, the rover went through an extremely complicated sequence of maneuver to land. From the fiery entry into the atmosphere, a supersonic parachute needed to deploy to slow the spacecraft. NASA officials said the parachute would need to withstand 65,000 pounds, means 29,480 kilograms, to break the spacecraft's fall to the surface. Under the parachute, MSL let go of the bottom of its heat shield so that it could get a radar fix on the surface and figure out in altitude. The parachute could only slow MSL to 2000 miles per hour, means 322 km per hour, for the far too fast for landing. To solve the problem, engineers designed the assembly to cut off the parachute and use rockets for the final part of the landing sequence. About 60 feet, means 18 meters above the surface, a sky crane deployed. The landing assembly dangled the rover below the rockets using a 20-foot, 6-meter tether falling at 1.5 miles per hour, means 2.4 km per hour. MSL gently touched the ground in Gale crater. About the same moment, the sky crane severed the link and flew away, crashing into the surface. NASA personnel tensely watched the rover's descent on live television. When they received confirmation that Curiosity was safe, engineers pumped first and jumped up and down in jubilation. Now, the news of the landing spread through traditional outlets such as newspapers and television, and well as social media such as Twitter and Facebook. One engineer became famous because of the mohawk he spotted on landing day. Tools for finding clues to life. The rover has a few tools to search for habitability. Among them is an experiment that bombards the surface with neutrons, which could slow down if they encountered hydrogen atoms, one of the elements of water. Curiosity's 7-foot arm can pick up samples from the surface and cook them inside the rover, suffering the gases that come out of there and analyzing them for clues as to how the rocks and soil formed. The sample analysis of Mars instrument, if it does pick up evidence of organic material, can double check out on Curiosity front. Under foil covers are several ceramic blocks refilled with artificial organic compounds. Related Curiosity rovers funds methane on Mars. Curiosity can drill into each of these blocks and place a sample into its oven to measure its composition. Researchers will then see if organics appear that were not supposed to be in the blocks. If so, scientists will likely determine these are organisms he's taking from Earth. High-resolution cameras surrounding the rover take the pictures as it moves, providing visual information that can be compared to environments on Earth. This was used when Curiosity found evidence of a stream, for example. In September 2014, Curiosity arrived at its science destination, Mount Sharp, Isles Mons. Shortly after NASA science review said the rover should do less driving and more searching for habitable destinations. It is now carefully evaluating the layer on the slope as it moves uphill. The goal is to see how the climate of Mars changed from a wet past to the drier, acidic conditions of today. I think the principal recommendations of the panel is that we drive less and drill more, Curiosity project scientist John Grotzinger said during a news conference at the time. The recommendations of the review and that was went to do as a science team are going to align because we have now arrived at Mount Sharp. Evidence for life, organic molecules and methane. Curiosity's prime mission is to determine if Mars is or was suitable for life. While it is not designed to find life itself, the rover carries a number of instruments on board that can bring back information about the surrounding environment. Scientists hit something close to the jackpot in early 2013 when the rover beamed back information showing that Mars had habitable conditions in the past. Powder from the first sample that Curiosity obtained included the elements of sulfur, nitrogen, hydrogen, oxygen, phosphorus and carbon, which are all considered building blocks or fundamental elements that could support life. While this is not evidence of life itself, the find was still exciting to the scientists involved in the mission. A fundamental question for the mission is whether Mars could have supported a habitable environment. As stated Michael Mayer, lead scientist for NASA's Mars exploration program, from what we know how, the answer is yes. Scientists also detected a huge spike in methane level on Mars in late 2013 and early 2014 at a level of about 7 part per billion compared to the usual 0.3 ppb to 0.8 ppb. This was a notable finding because in some circumstances methane is an indicator of microbial life, but it can also point to geological processes in 2016. However, the team determined that methane spike was not a seasonal event. There are smaller background changes in methane, however, that could be linked to the seasons. Curiosity also made the first definitive identification of organics on Mars. As announced in December 2014, organics are considered life's building blocks but do not necessarily point to the existence of life, and they can also be created through chemical reactions. While the team cannot conclude that there was life at Gill crater, the discovery shows that the ancient environment offered a supply of reduced organic molecules for use as building blocks for life and an energy source for the life NASA stated at the time. Initial results released at the Lunar and Planetary Science Conference in 2015 showed scientists found complex organic molecules in Martian samples stored inside the Curiosity rover, but using the unexpected method in 2018, results based on Curiosity's work added more evidence that life was possible on Mars. One study described the discovery of more organic molecules in 3.5 billion years old rocks, while the other showed that methane concentration in the atmosphere changes seasonally. The seasonal changes could mean that the gas is produced from living organisms, but there is no definitive proof of this yet. Checking out the environment. Besides hunting the habitability, Curiosity has other instruments on board that are designed to learn more about the environmental surroundings. It among those goals, it have to a continuous record of weather and the radiation, the observations to determine how suitable the site would be for an eventual human mission. Curiosity's radiation assessment detector RAD runs for 15 minutes every hour to measure a swath of radiation on the ground and in the atmosphere. Scientists in particular are interested in measuring secondary rays or radiation that can generate lower energy particle after it hits the gas molecules in the atmosphere. Gamma rays or neutrons generated by the process can cause a risk to humans. Additionally, an ultraviolet sensor stuck on Curiosity deck tracks radiation continuously. In December 2013, NASA determined the radiation level measured by Curiosity were manageable for a crewed Mars mission in the future. A mission with 180 days flying to Mars, 500 days on the surface, and 180 days heading back to Earth would create a dose of 1.01 sieverts. Curiosity's radiation assessment detector determined the total lifetime limit for European Space Agency astronaut is 1 sievert, which is associated with a 5% increase in fatal cancer risk over a person's lifetime. In the rover environmental monitoring stations measure the wind speed and chart direction as well as determining temperature and humidity in the surroundings air. By 2016, scientists were able to see long-term trend in atmospheric pressure and air humidity. Some of these changes occurs when the winter carbon dioxide polar caps melt in the spring, dumping huge amounts of moisture into the air. In June 2017, NASA announced that Curiosity had a new software upgrade that would allow it to pick targeted by itself. The update called Autonomous Exploration for Gathering Increased Science, AEGIS. Autonomous Exploration for Gathering Increased Science, AEGIS, represents the first time artificial intelligence was deployed on a faraway spacecraft. It was first time artificial intelligence was deployed on a faraway spacecraft. In early 2018, Curiosity sent back pictures of creatures that could have formed from ancient lakes on Mars. There are multiple hypotheses for these features, but one possibility is that they formed after the salts concentrated in evaporating water lake. Some internet rumors speculated the features were actually signs of burrowing life, but NASA quickly discounted that hypothesis based on their linear angles, a feature that is very similar to crystalline growth. Issues with the rover. Vapors from the wet chemistry experiment filled with a fluid called MTBSTFA, N-methyl, N-tert dimethyl trifluorocetamide, contaminated a gas sniffing analysis instrument shortly after Curiosity landed. Since the scientists knew the collected samples were already reacting with the vapor, they eventually dragged away to seek the preserve the organic after extracting, collecting and analyzing the vapor. Curiosity had a dangerous computer glitch just 6 months after landing that put the rover within only an hour of losing contact with Earth forever. NASA revealed in 2017 another brief glitch in 2016 briefly stopped science work, but the rover quickly resumed its mission. In a month after landing, NASA noticed damage in the rover's wheels appearing much faster than expected. By 2014, controllers made in the rover's routine to slow down the appearance of the dings and holes. They are taking damage. That is the surprise. We got back to that at the end of last year, said Jim Erickson, Curiosity project manager at NASA Jet Propulsion Laboratory, JPL, in Pasadena, California, in a July 2014 interview. We always expected we could get some holes in the wheel as we drove. It is just a magnitude of what we are seeing that was the surprise. NASA pioneered a new drilling technique at Mount Sharp in February 2015 to begin operations at a lower setting, a requirement for working with the soft rock in some of the region. Previously, a rock sample shattered after being probed with the drill. Engineers had mechanical trouble with Curiosity, drill starting in 2016 when a motor linked with two stabilizing posts on the drill bits ceased working. NASA examined several alternative drilling techniques, and on May 20, 2018, the drill obtained its first sample in more than 18 months. Related mission and future missions. It should be noted that Curiosity is not working alone on the red planet. Accompanying it is a team of other spacecraft from several countries, often working collaboratively to achieve science goals. NASA's Mars Reconnaissance Orbiter provides high-resolution imagery of the surface. Another NASA orbiter called MAVEN, Mars Atmosphere and Volatile Evolution Mission, MAVEN, Mars Atmosphere and Volatile Evolution Mission, examine the Martian atmosphere for atmospheric loss and other interesting phenomena. Other orbiting missions include Europe's Mars Exploration, the European ExoMars Trace Gas Orbiter, and India's Mars Orbiting Mission. As of mid-2018, Curiosity is working on the surface along with another NASA rover called Opportunity, which has been roaming the surface since 2004. Opportunity was initially designed for a 90-day mission but remains active after more than 14 years on Mars. It also found past evidence of water while exploring the plains and two large craters. NASA's Mars Odyssey acts as the communication relay for Curiosity and Opportunity while also performing science of its own, such as searching for water ice. More surface missions are on the way shortly. NASA's InSight mission, a stationary lander designed to probe the interior Mars, launched for the Red Planet on May 5, 2018 and is expected to land on November 2018. The European Space Agency ExoMars rover should launch for Mars in 2020 to search for evidence of ancient life. And NASA also plans a successor rover mission called Mars 2020, which is closely based on Curiosity designs. Mars 2020 will carry different instruments, however, to better probe for ancient life. It will also catch a promising sample for a possible Mars sample return mission in the coming decades. In the most distant futures, NASA has talked about sending a human mission to Mars, perhaps in the 2030s. In late 2017, however, the Trump administration tasked the agency with sending humans back to the moon. First, the administration has also requested that funds for the International Space Station ceases in 2025, in part to make budgetary room for a moon space station's initiative called the Deep Space Gateway. In my next video, I will reveal some true facts of other more interesting science topics. Thanks.